Today we're going to find the derivative of functions in terms of ln. So we know that in our formula, the derivative rule for finding the derivative of ln u, where u is any function, is simply 1 over u times du all over dx. So this is what we're going to be using in finding the derivative of these functions. So let's start with problem number 1. With problem number 1, we need to find the derivative of ln 2x, where u is 2x. So to find the derivative of that, we're simply going to use the formula 1 over u, which is 2x, times the derivative of u, which is 2x. We know that the derivative of 2x is simply 2. So going back to 1 over 2x, the derivative of ln 2x is simply going to be 2 all over 2x, or 1 over x. So this is how we use the derivative rule in finding, the derivative rule for ln u. Now let's go ahead and answer problem number 2. And in problem number 2, our function will be, or our problem will be to take the derivative of ln 2x squared plus 1. And we know that u is 2x squared plus 1. So to take the derivative of that, it will be 1 all over 2x squared plus 1 multiplied by the derivative of 2x squared plus 1. So we know that the derivative of 2x squared plus 1 is simply 4x. And we are just going to multiply it with 1 all over 2x squared plus 1. So our derivative function will simply be 4x all over 2x squared plus 1. So that's how simple using the derivative rule is for ln. And for problem number 3, we have to take the derivative of ln x raised to 3. So here we will be using chain rule plus the derivative of ln u. So we're going to use two derivative rules in finding the derivative of problem number 3. So let's go ahead and use the chain rule for ln x raised to the third power. So it'll be 3 multiplied by ln x times 2 times the derivative of the inside, which is ln x. So we know that the derivative of ln x is 1 over x times du dx, which is 1. We just have to multiply it by 3 ln x squared, and we're finished. We now have the derivative of function for problem number 3, and if we're going to simplify it further, it will simply be 3 times ln x raised to 2 divided by x. So that's problem number 3. For problem number 4, we have f of x is equal to ln square root of x plus 1. So in this particular problem, for number 4, 5, and 6, this is problem number 6. We're going to be using the properties of logarithm, or expansion of logarithms, to be able to differentiate the functions for 4, 5, and 6. Now, first, let's modify our number 4 function into ln of x plus 1 raised to 1/2. And using the power property of logarithm, we can modify the function into 1/2 ln of x plus 1. And by doing so, we're now going to be using the derivative rule for constant multiplied by a function. So here, we're just going to ignore or just simply put 1/2 on the side and take the derivative of 1 over or x plus 1, which is going to be 1 over x plus 1 times d dx of x plus 1, which we know is simply 1. So we'll have 1 over x plus 1 for the derivative of ln x plus 1. So f prime of x is simply 1/2 multiplied by 1 over x plus 1. And if you want to simplify this further, we can rewrite this as 1 all over 2 parentheses x plus 1. So this is how we find f prime of x, or the derivative of the function ln of square root of x plus 1. Now let's have problem number 5, which is a little bit complex or more complicated than problem number 4. So what we're going to do is, instead of using the quotient rule, which is 1 over u du dx, we're going to expand our logarithm. So we're going to rewrite the function before we take the derivative. So f of x, using the properties of logarithm, can be modified into ln x plus ln of x squared plus 1 squared minus ln of 2x squared minus 1 raised to 1/2. So this is how we expand using the product property and the quotient property of logarithm, but we can simplify this further by using the power property. So we have ln x plus 2 ln of x squared plus 1 minus 1/2 ln of 2x squared minus 1. And now we have 3 different set of terms or functions that we can derive using the derivative rule for logarithm.
Attention, custodian, room 71. If we could have Manuel go to room 71 and lock the door for a student to pick up an item. Again, room 71 needs to be open for a student to pick up an item.
So let's go ahead and take the derivative of each term. So derivative of the first term is simply 1 over x times 1, which is the derivative of x, added to this one. So this one, we ignore the constant and take the derivative of ln x squared plus 1, which is 1 over x squared plus 1 times the derivative, which is 2x. And the third term is 1/2, so ignore 1/2 right here, put it aside, and take the derivative of ln 2x squared minus 1. So we have 1 over 2x squared minus 1 times the derivative of 2x squared minus 1, which is 4x. So now we have f prime of x. And to simplify our derivative function further, we can clean this up. So we'll have f prime of x is equal to 1 over x for our first term. For our second term, we can multiply these two together. So we'll have 4x all over x squared plus 1 minus, in this case right here, we can multiply 4 by 1/2. So we'll have 2x over here. So 2x all over 2x squared minus 1. So this is now our derivative for problem number 5 by expanding the function using the properties of logarithm. Now for number 6, it's a little bit different from the rest of the problems, because here we have y equals x raised to the square root of x. So this is an example of the derivative for a function raised into another function. So it's not going to be e to the u du dx, or it's not going to be a constant raised to a power. So when this particular function happens, what we can do is we're going to multiply both sides by ln, and we'll be able to differentiate this function in terms of the logarithmic rule. So we'll have ln of y equals ln of x raised to square root of x. So we basically multiply both sides by ln, and using the power property of logarithm, we can modify the right side of the equation into square root of x multiplied by ln x. So now we know that we're going to be using the product rule later on to find the derivative of this side of the equation. So let's go ahead and take the derivative of ln y, and the derivative of ln y with respect to x would be 1 over y times dy dx, because we are differentiating in terms of x, so we're using implicit differentiation. And for the second one, or the other side of the function, we will be using the product rule. So let's say I'll take the derivative of the first term. This is my first term, which is 1/2 x raised to the negative 1/2 multiplied by, just copy ln x, add it to the copy of the first term, multiplied by the derivative of the second term, which is 1 over x. And the derivative of x is simply 1. So now we have 1 over y prime equals 1 over 2 square root of x multiplied by ln x plus square root of x all over x. So this is now the derivative function, but we need to have y prime by itself. So what we're going to do is we're going to multiply both sides of the equation by y, so we can get rid of this using algebra, and now y prime is by itself. So by modifying our function, y prime is now going to be ln x all over 2 square root of x plus square root of x all over x multiplied by the y function, which we know is x raised to the square root of x, so we can rewrite it as x squared of x. So this is now the derivative of our function y using the properties of logarithm and the rule of the derivative of ln.